In our previous lessons, we were looking at integers. Now, these are very useful if all you need to do is count. However, there are a lot of different numbers that we can use for many other things that we don't get by counting. Some of these numbers are what we call the rational numbers. So as a reminder, a fraction is a number written down as the ratio, or we could say quotient or division, of two numbers. In fact, fractions, ratios, quotients, divisions, these are all the same thing. We just tend to think of them in different ways, but mathematically they describe the same type of number. Now, a fraction contains a numerator, which is the number on the top, and a denominator, which is the number on the bottom. The numerator describes the number of parts we're interested in, whereas the denominator describes the number of parts that make up a whole. Now, a rational number is a number which can be written as a fraction, but only if we're using integers for both the numerator and the denominator. So, for example, the numbers -19, 2.8, and 0.3 repeating are all rational numbers because we can write them as fractions. Now, for this lesson, we're not going to see how we can actually go and find these fractions. It's enough for us to know that they exist, but in a future lesson, we'll see how we can actually calculate what these fractions are. But we can generalize these results a bit more. As it turns out, all integers are rational, all terminating decimals are rational, and all repeating decimals are rational. Now, for the rest of this lesson, we're going to look at some basic fraction concepts. Hopefully these are things that you've seen before, but they're very important concepts for us to understand the work we're going to be doing in the future. So let's make sure we properly understand the way that fractions work. Firstly, fractions are equivalent if they represent the same number. So for example, we want to show that 2/3 and 8/12 are equivalent. Well, to show 2/3, we split a whole bar into 3 parts and we choose 2 of them. To show 8/12, we split a whole bar into 12 equal parts and we choose 8 of them. Now, when we have our fraction bars drawn side by side, we can easily see that these two fractions represent the same amount. However, drawing an accurate diagram every time we want to show that fractions are equivalent is not the most practical thing to do. So let's look at how we could actually work out that these fractions are equivalent without involving a diagram. Notice that for every one section in the 2/3 bar, we get 4 sections in the 8/12 bar. Really, these fractions are the same, it's just in 8/12 we've split each section into 4 further sections. We can show this numerically by taking 2/3 and multiplying both our numerator and denominator by 4, and we get 8/12. We could show the exact same thing the other way by starting with 8/12 and instead dividing both the numerator and denominator by 4 to get 2/3. Either one of these approaches shows that these two fractions are equivalent. Now, a fraction can be simplified, that is, written in the form that's equivalent but has the smallest numbers making up the numerator and denominator, by dividing both the numerator and the denominator by their greatest common factor. That just means the biggest number that goes evenly into both of those numbers. So if we have 10/35, we look for the largest number that is a factor of both 10 and 35. That number turns out to be 5. Dividing both 10 and 35 by 5, we get 2/7. 20 and 32 have a greatest common factor of 4. So we can divide both 20 and 32 by 4 and we get 5/8. Now, when fractions have different denominators, it's difficult to order and compare them. So it's useful to write them with a common denominator. The simplest way to do this is using the least common denominator, which is the least common multiple of the denominators. That is, the smallest number that's a multiple of both denominators. So for example, we want to compare 2/5 and 3/7. Now, when we have fraction bars, which are split evenly into 5 parts and 7 parts, we can shade 2/5 and we can shade 3/7, and we can see immediately that 3/7 is larger than 2/5. However, drawing this type of diagram is not the most practical way of finding which of these two fractions is greater. Let's instead find a common denominator for these two fractions. Well, the smallest number that's a multiple of both 5 and 7 is 35. And we can see that with the dotted lines that divide up the fraction bars even further into 35 sections. We see that 2/5 becomes 14/35 and 3/7 becomes 15/35. Now that we have a common denominator, we see that 15/35 is greater than 14/35, so 2/5 is less than 3/7. If we want to order three fractions, such as 3/4, 5/6, and 2/3, we need to find a common denominator for all of them. Well, the smallest number that's a multiple of 4, 6, and 3 is 12. So we can write each of these fractions as a fraction with a denominator of 12, and we get 3/4 is 9/12, 5/6 is 10/12, and 2/3 is 8/12. By comparing their numerators, we have their order, and so 2/3 is less than 3/4, which is less than 5/6. Now, all the fractions we've worked with so far are called proper fractions. A proper fraction is a fraction whose numerator is less than the denominator, which means the value of the fraction is between 0 and 1. But often, we want to represent rational numbers whose values fall outside of that range. In that case, we can represent it as either a mixed number, which is the sum of an integer part and a proper fraction, or we can represent it as an improper fraction, which means the numerator is greater than the denominator. Often we want to convert between these two representations. For example, 2 and 3/4 is a mixed number. If we want to work out what it is as an improper fraction, we need to work out how many quarters fit into 2 and 3/4. Remember, a quarter really just means we split a whole into 4 parts. So 2 just means we have 2 lots of a whole. 2 lots of 4 means that represents 8 parts. So in total, we have 8 parts from the 2, and we have 3 parts from the 3/4. In total, the number of parts we have is 8 plus 3, which is 11. So our improper fraction is 11/4. Let's follow the process the other way to write the improper fraction 25/7 as a mixed number. Because this fraction has a value larger than 1, it contains integer parts which we can separate from a proper fraction part to get our mixed number. Now we can't write 25/7 equally as an integer. However, we can write 21/7 equally as an integer because 21/7 is equal to 3. So 25/7 is the same as 21/7 and 4/7, which is the same as 3 and 4/7.